Hello Year 7 and Year 8. This is going to be your yeast experiment. We're trying to find out in this what conditions it is that yeast likes to grow and to multiply in. When yeast multiplies, it produces a gas called carbon dioxide. And so what we're wanting when we're making bread is for yeast to ferment, multiply and to produce CO2, as that carbon dioxide or CO2 will help our bread to rise. And we don't want bread that's heavy and dense. We want aerated, well-risen bread. So I've got for you 6 bottles and I've got different conditions in each bottle. Now you need to be having up in front of you your team's assignment, and you're going to pause this video at various points. Okay, it might be you need to go back and re-watch parts of this video, and that's okay. So in each bottle there are different conditions for the yeast. The last bottle that I haven't added any yeast to yet is this one here. So I'm just using a funnel, adding a sachet of yeast. And there's a sachet of yeast gone into each of these 6 bottles. Now each of these 6 bottles will then have different temperatures of water to see if yeast is affected by the temperature that we give it. Then some of the yeast is just left on its own with that temperature of water, and some yeast has got sugar in with it to see if it likes having sugar in with it. There's one bottle, this one here, bottle 4, which has also got salt in. This is going to mirror what we're doing with our bread making recipe. So I'm just going to allow you a moment because I've asked you to write in your table what the different conditions are. So I'm going to allow you a moment to see what bottle 1, 2, 3, 4, 5, 6 has in it. And you'll be able to pause the video to write that on your assignment sheet. Okay, so you've now seen what's in each of these bottles. Now the bottles are going to have water added to them at different temperatures. Now the temperatures that I've got, and I've got the 3 different temperatures of water here, are boiling, and the boiling water was at 91 degrees C just a moment ago. The warm water, that was 48 degrees C a couple of moments ago. And the cold water I've tried to get really cold for you because it's quite a nice sunny warm day here, so I've put some ice cubes in with it to cool it down. And the cold water was 9 degrees C. Now the water's going to be put in, and I'm going to try and get it to roughly the same level in each bottle. I could weigh the water and add it in so it's an exact amount to make the experiment more fair. However, what I've done is I've put little lines on the back of each bottle that are roughly the same height, so that roughly I will have the same amount of water in. Once the water goes in, I'm then going to place a balloon over the top of each bottle. I'll give it a shake so that the yeast mixture is all mixed up in there, and then I will put a balloon on top. The idea of the balloon is that as the yeast ferments and multiplies, it produces carbon dioxide. And the carbon dioxide will escape, and as it escapes, we're going to be able to capture it in the balloon. Now this is my strange logic on this. I always feel that cold water, that's a cold colour, so I've given those 2 blue balloons for the cold water that's going into these bottles. The warm water, well, I thought that's red, that's warm, it's hot feeling, so they've gone for red. The boiling water, I only had an orange balloon for that one, so that's got an orange balloon, but that's why the balloons are the colour that they are. Now already in these bottles, if I just do this, you can see that I've put in already any sugar that was needed and any salt. So any of the bottles that say that they should have sugar in, you will see that at the bottom there is some white where the sugar has gone in, and this one has also got salt in. I put a teaspoon of sugar in the ones that had sugar and a teaspoon of salt in for the ones that had salt in. So starting off then with the boiling water, I'm going to pour this into the bottle very carefully because obviously it's boiling water. Now you're not going to be doing this experiment at home because at school we would do the experiment like this as a class. So this will be your results from this science experiment. So you don't need to worry about completing this at home. This is now just for you to be able to watch, try and understand the science behind it, and then write it up a little bit. So these next three all have warm water. So 1, 2, oops, a bit sticky left on that bottle. The bottles had water in them only, and the bottles were rinsed out before use. Yeah. And now I've got to move on to the cold water for these last 2 bottles. Trying to find the line on this one. So at this stage they've all got the yeast in, they've all had a sachet of yeast. The ones that needed sugar have got sugar in, the ones that needed salt have got salt in. They've now got water to approximately the same line, but I want you to think about some fair testing, which is on your assignment sheet in a moment. And now the last thing for me to do is to take the lid for the bottle so that I'm able to safely give these a shake so that the yeast isn't all stuck in the bottom, in the lugs at the bottom there. And then I will put a balloon over the top of each of these bottles. And I'm going to pause the video now while I just do that for you, and then I'll show you once the balloons are all in place. So our bottles have now all had a shake so that the yeast isn't stuck at the bottom or the sugar isn't stuck at the bottom or salt. And then I put the balloon, and as I told you with my strange logic, the balloon's gone on top of these. And now yeast generally needs time to work because it takes between 10 and 20 minutes for bacteria and other microorganisms to multiply. Now yeast isn't bacteria, but it is a microorganism, so we're going to give it probably about half an hour. Now it's quite a nice warm day here at this point in time, so it might work quite nice and quickly. To remind you then, in case you didn't catch the temperatures of the water in the bottles, boiling water was 91, the warm water was 48 degrees, and the cold water was 9 degrees. Okay? Now you need to make predictions, and the idea of this is, just to remind you, that as the yeast ferments and multiplies, it produces CO2. The CO2 it produces is trapped in our balloons. So we would expect that as the yeast is working and multiplying, that our balloons should inflate. And then the happier that the yeast is, means it's multiplying more, which means it's producing more CO2. So the balloon, which is the biggest at the end, should mean that we've found a condition that yeast is most happy to multiply in, and therefore we can then say when we make our bread that this would be a sensible way and sensible conditions to give the yeast. So as I say, I'm going to let you go away, I'm going to let you write up your predictions and fill in any bits of the sheet that you can, but hold off from the bits that are after the table, because after the table is you thinking about the results. So don't do anything for that for just a moment, but come back to me when you've written up all of your predictions and all of the answers up until the table, and then after we've seen the results you can finish off your actual results on your table and also write in the other questions that you've got to answer. I'll rejoin you in a little while then. Thank you. So about 20 or 25 minutes have passed, and I'm just rejoining this experiment for you so you can take a look at the results. Now the first thing to notice is they're still in their order of bottle 1, 2, 3, 4, 5, 6. I want you to have a look at the balloons. I want you to make a note of which balloons are inflated and which balloons are biggest and which balloons haven't inflated at all. The next thing I'd like you to do is to have a little look inside the bottles. So I'm going to turn them around ever so slightly, and then I'm going to let you have a little look, and they're still going to be in 1, 2, 3, 4, 5, 6 order. And hopefully you might still be able to see the number that's on there. And I want you to see, when you look inside the bottle, what you can see. So if I just allow you to have a moment just to look through these as you can see them. Okay, there's a few interesting things to point out to you. I've asked you to talk about foam in your results section. So once you've talked about which balloon is the biggest and which is the happiest yeast, the next thing to talk about is the foam. Now, when yeast multiplies and produces CO2 and ferments, it produces a foam. You can see in this bottle here, with the biggest balloon, that there's a lot of foam being produced by the CO2, by the yeast. There's a lot of CO2 bubbles in there, and if you have a real close look at that, you will see that that foam is made up of bubbles of CO2, and the same in bottle 4 with the warm water, sugar and salt. So the foam is produced by the yeast. You might be able to make some generalisations here, that the happier the yeast is, the more foam it's produced. You might be able to now tell me which conditions the yeast likes best. You might be able to start telling me which conditions the yeast does not like so much. One bottle that I'm going to show to you is the boiling water and point out to you. If you notice with the boiling water, whereas all of the other bottles have got even just a little bit of foam on it, the one with boiling water has got no foam at all. And if you look closely, there's a line where it's like a liquidy water on top and then it's brown liquid on the bottom. In this bottle, the yeast has been killed. So the yeast is not active, the yeast will not multiply, and therefore if you used boiling water for bread making, your bread would not rise. It's also, because the water is so hot, made the bottle change shape, and it's also sucked the balloon in almost, because it couldn't, the water was too hot for the bottle. Now, there's various questions that you've been asked to fill in here, and I'd like you to start thinking about what you can say from this experiment, which conditions the yeast likes best, therefore what conditions you're going to give your bread when you make it, and in future, maybe if you're making bread in the future, what you would do to make your bread rise as much as possible. But hopefully this has given you very visually some results that show you what yeast likes and what yeast does not like. Thank you very much.